In this problem, we are electrolyzing a solution of cobalt ions, and those cobalt 2+ ions are being reduced down to cobalt solid. So our first step is to identify the chemical reaction that is occurring, and that is cobalt 2+ is gaining 2 electrons and reducing down to cobalt solid. And this question is asking us to calculate the mass of cobalt in grams produced when we pass 15 amps of current through the solution for 1 hour. So a couple of things about vocabulary here. Capital A stands for amps, and an amp is coulombs per second. Coulombs is often abbreviated with a capital C. So you can think of this 15 amps as 15 coulombs per second. So we know that this is going to run for 1 hour, and 1 hour is your time, and that is equal to 60 minutes. But I also know that there are 60 seconds inside of 1 minute. So I know that the total time in seconds has to be 3,600 seconds. All right, so now for all of the dimensional analysis, it starts with how much time we are going to run this cell, and it's 3,600 seconds as your starting point. And we know that the current is 15 amps, or in other words, 15 coulombs per second. So I'm going to put 15 coulombs over 1 second. So seconds cancel out. And now I'm going to refer to Faraday's constant, which is F. Faraday's constant is 96,485 coulombs per 1 mole of electrons. So that's my unit conversion between coulombs and moles of electrons. So 1 mole of electron is equal to 96,485 coulombs of charge. Coulombs cancel out, and we now need to cancel out those moles of electrons. According to the balance equation that we wrote, for every 1 mole of cobalt solid that's produced, 2 moles of electrons are needed, and that's just stoichiometry, looking at the coefficients of the cobalt solid and the coefficient of the electrons. So moles of electrons cancel, and then one last step, I'm going to convert the moles of cobalt into grams using the periodic table. It has a mass of 58.93 grams for every 1 mole. So 1 mole of cobalt cancels out, and now we solve, and we get an answer of 16 grams of cobalt that will be produced when we run 15 amps of current through this electrolytic cell for 1 hour.